interrupt our program to bring you this important message.
Laura slamming the Gulf Coast.
2020 shattering records around the world for some of the wildest weather ever recorded.
Deadly wildfires raging up and down the West Coast.
Go, go, go!
More than 10 million acres charred, mostly in California, Colorado, and the Pacific Northwest.
End the word climate change and own up to the fact it is the climate crisis now.
Climate change is now rapid, widespread, and intensifying.
Unequivocal that human activities are responsible for climate change.
Let's terminate pollution.
Climate change, pollution, and the ever-growing global population is directly impacting and damaging the world around us. As the global population increases, so does the use of fossil fuels and non-biodegradable materials. The increased use enhances climate change and pollution respectively. With polluted waters and expensive filtration systems, water insecurity has never been higher and is expected to grow. The Sustainable Bio-Based Materials Lab at Auburn University is working with plants, extracting nanocellulose and natural polymers to create affordable and environmentally safe ways to develop plastics and water filtration systems. This technology has the potential to solve major issues that enhance climate change and pollution.
My name is Soledad Perecin. I'm an associate professor at Forest Biomaterials at the College of Forest and Wildlife Sciences at Auburn University. Natural polymers are the building blocks of lignocellulosic biomass, which is the trees and plants that we can find in the environment. So we can take apart the trees and the plants and bring them down to their units like cellulose or lignin or other sugars, and then we can use those to manufacture new products that we can use as replacement of commodity plastics, for example. Cellulose fibers can be broken into nanoparticles, called nanocellulose, that they have higher area to bond with contaminants, and we can also add chemical modifications to it that they will make them more appealing to be used in applications such as water remediation. In addition to this, we can use cellulose in packaging applications. We all know paper. Paper is made of trees and sustainably managed forests. Cellulose can be used in packaging products, and we can use green chemistry approaches to modify these natural polymers and come up with an array of products.
Nanocellulose is exactly as its name suggests, nanometer-sized plant cellulose. Cellulose is an insoluble substance that is the main constituent of plant cell walls. As Dr. Perecin mentions, cellulose can be found in all plants and trees. Plants and trees are a renewable, biodegradable substance, making it a sustainable and environmentally friendly choice when developing materials. Scientists can remove the material from plants through the use of acids, enzymes, or mechanical processes. The materials are then modified through nanocrystal synthesis, physical absorption, or chemical modification. These processes are what allows nanocellulose to offer many uses and products. These modifications affect the structure and chemistry of the material. This is what allows nanocellulose to be made into plastics and packaging. Its modifications decrease oxygen diffusion, far better than the plastics made of non-renewable fossil fuels. In other words, foods packaged in nanocellulose packaging will last longer, cost less to produce, and are biodegradable, so they will not pollute and damage the environment. Other modifications can create nanocellulose filtration systems. Traditional water filtration is composed of expensive, non-renewable chemicals and materials. Nanocellulose is an inexpensive, reusable method that has been proven to filter better than traditional methods. Nanocellulose has a high surface area. Increasing the surface area of a reactant increases the frequency of collisions and increases the reaction rate. This means nanocellulose adheres to contaminants very well, effectively removing harmful substances from the water. These filters do not go to waste. They are biodegradable and can be reused over and over again. More importantly, this process is extremely affordable to create and can be used in any area around the world, unlike traditional filtration methods. Nanocellulose filtration systems could be the solution for solving water insecurity and decontamination across the globe. Foresters and scientists have developed ways to sustainably manage and use trees to create pulp and paper. Tree pulp is the most common material used to create nanocellulose technology. Tree pulp is made and used in paper mills. In theory, the leftover pulp can be used to create nanocellulose technology and increase the sustainability of product production. Additionally, paper mills have the potential to create their own energy through cogeneration. The heat and steam that are produced through the drying section of the paper mill can be converted into electricity, allowing the mill to produce its own energy and increasing sustainability by decreasing the ecological footprint and carbon emissions. Therefore, we can make plastics, papers, and water filtration at almost no cost to the environment. Climate change and pollution are deeply affecting and damaging the world. However, the solutions to these issues are all around us. Nanocellulose is an innovative, sustainable, and affordable solution for the many environmental issues our world is facing. Through sustainability, a healthier, greener world is possible.